If you have ever wondered what fire is made of, you might be surprised to learn that it is not a simple question to answer. Fire is the result of a chemical reaction called combustion, which involves a fuel and an oxidizer. However, the exact composition and state of matter of fire depend on the type of fuel, the oxidizer, and the conditions of the reaction. Fire is one of the most complex and mysterious phenomena. Fire is a repeated chemical reaction that releases heat and light when a combustible material comes in contact with oxygen. Fire can only exist when there is enough oxygen, fuel, and heat in the environment. Combustion and fire are closely related terms, but they are not the same thing. Combustion is a chemical process that occurs when a fuel, such as wood or coal, reacts with the oxygen to release heat, light, and various gases. This process typically requires a specific amount of heat, called the ignition temperature, to start, and it can be controlled or stopped by adjusting the fuel, oxygen, or heat levels. The combustion process releases heat and light, which we perceive as fire. The main components of fire are fuel, the substance that burns, such as wood, gas, oil, etc. Oxygen, the gas that supports combustion, usually from the air. Heat, the energy that initiates and sustains the combustion reaction. Flame, the visible part of fire, consisting of hot gases and glowing particles. Smoke, the mixture of gases, particles, and water vapor that is produced by incomplete combustion. The color and shape of fire depend on several factors, such as the type and amount of fuel, the availability of oxygen, the temperature and pressure of the environment, and the presence of impurities or additives. For example, a candle flame is yellow because it contains small soot particles that glow when heated. A gas stove flame is blue because it has enough oxygen for a complete combustion and does not produce soot. A firework flame is colorful because it contains metal salts that emit different colors when heated. We usually learn that there are three states of matter: solid, liquid, and gas. However, fire does not fit neatly into any of these categories. Fire is mostly a state of matter called plasma. Plasma is a gas like state where the atoms are so hot that they lose their electron and become ionized. Plasma is often considered the fourth state of matter after solid, liquid, and gas. Plasma is what makes fire glow and emit light. However, not all parts of fire are plasma. Some parts are still in the gas state, such as carbon dioxide and water vapor. Some parts are even in the solid state, such as soot particles. The exact portion of plasma, gas, and solid fire depends on the temperature and intensity of the combustion reaction. As we have seen, fire is not a uniform phenomenon. There are many types of fire that differ in their composition and characteristics depending on the fuel and oxidizer. Fire can be classified into different types based on the fuel source and the mode of combustion. Based on fuel source, some common types of fire are Class A, fires involving ordinary combustible materials such as wood, paper, cloth. Fire B is fires that involving flammable liquids or gases such as gasoline, alcohol, propane, etc. Class C is fires that involving energized electrical computer wires. Class D, fires involving combustible metals such as magnesium, sodium, potassium, etc. Class K, fires involving cooking oils or fats. So fire based on behavior are flame. A flame within is a one that is luminous zone of burning gas that emits light and heat. Flames can have various colors such as yellow, orange, red, blue, or white depending on the temperature and composition of the gas. Flames can have different shapes such as conical, spherical, cylindrical, or irregular depending on the flow and direction of the gas. Then smoldering, a slow, low temperature combustion process that occurs in the absence of flames. Smoldering involves the oxidation of solid fuels such as wood, coal, or tobacco that produce smoke and ash. Smoldering can be initiated by heat sources such as sparks or embers, or by chemical reactions such as oxidation or pyrolysis. Spontaneous combustion, a type of fire that occurs when a material ignites without any external heat source or flame. Spontaneous combustion can be caused by chemical reactions such as oxidation or decomposition that generate enough heat to ignite the material. Some examples of materials that can undergo spontaneous combustion are hay, coal, oil, rags, or compost. Flash over, a sudden and rapid spread of fire throughout a confined space due to the simultaneous ignition of combustible gases and vapors. Flash shower can occur when the temperature inside a room reaches a critical point that causes all the exposed surfaces to emit flammable gases. Flash shower can result in high temperatures, intense flames, and thick smoke that can pose a serious threat to firefighters and occupants. Humans are the only animals that can create and control fire, using it for various purposes such as cooking, heating, lighting, protection, and communication. The ability to use fire give humans an edge over other animals, allowing them to expand their diet, increase their brain size, reduce their body hair, colonize new environments, and develop complex cultures. Earth has the right kind of atmosphere that allow coexistence of fire and biological creature capable of using it. Fire need to have an atmosphere that supports both human respiration and combustion. That's a very special quality. That atmosphere, the only viable one is in Earth, where it at the one time supports fire and at the other time also supports the respiration of human, which makes it a very unique kind of a thing. Fire has been a crucial factor in the development of human civilization. Some of the most significant innovations are cooking. Fire allowed humans to cook food, which made it easier to digest and increased its nutritional value. Cooking also reduced the risk of foodborne diseases and parasites and expanded the range of edible foods. Tools. Fire enabled humans to create and use tools made of metal such as knives, axes, spears, hammer. Metal tools were stronger, sharper, and more durable than stone or wood tools. They also allowed humans to hunt, farm, and build efficiently. Fire is used for scientific and technological purposes such as combustion, metallurgy, and pyrotechnics. Steam engine, glass is used for telescopes and microscopes, cars, planes, and many other things, right? Has made all this progress possible. In art, fire inspired humans to create various forms of art, such as pottery, glass, metalwork, and painting. Fire also provide light and warmth for artistic activities. Art expressed human creativity, emotions, beliefs, and values, and enriched human culture. In science, fire stimulated human curiosity and experimentation. Humans learned how to control fire, use it for different purposes, and understand its properties and effects. Fire also led to the discovery of other phenomena such as electricity, magnetism, and chemistry. One of the most obvious effects of a fireless Earth would be the accumulation of dead organic matter on the ground. This will reduce the availability of nutrients for plants and increase the risk of pest outbreaks and diseases. It will also alter the composition and structure of ecosystems, favoring species that can tolerate low light and low nutrition conditions such as ferns and mosses. Another consequence of a fireless Earth would be the reduction of atmospheric oxygen. Fire is one of the main sources of oxygen in the atmosphere as it releases oxygen from plants during combustion. Without fire, oxygen levels would drop over time, affecting the respiration of animals and humans. Some scientists estimate that without fire, atmospheric oxygen would fall below 10%, making Earth uninhabitable for most life forms. A third impact of fireless Earth would be the disruption of the global climate. Fire affects the climate in several ways, such as changing the albedo reflectivity of the surface, emitting greenhouse gases and aerosols, and altering cloud formation and precipitation patterns. Without fire, Earth would likely become cooler and wetter in some regions, and warmer and dry in others. The changes in temperature and moisture would affect the distribution diversity of life on Earth. Fire is an intriguing phenomenon that involves complex chemical reactions between fuels and oxidizers. Fire is not a single substance, but a mixture of different components and states of matter. Fire can vary in its composition, color, temperature, and effect depending on the type and conditions of the combustion reaction. Fire is an essential element of Earth's biosphere. Without it, Earth would lose its dynamic and complex character and become a less habitable place for life, or even it can extinct life without life we can extend without fire. Fire has very unique features which are of immense human benefits. Why it has these features and how it acquires them? Why Earth is the only planet which simultaneously support both combustion and respiration? Because it has an ideal size and ideal atmosphere, right, which supports both it. Otherwise, it can do not work in other environments and atmosphere. Fire is available. The next is fire is available naturally. Why only humans can control it?